A slight pressing of the accelerator, a slight rush of adrenaline, result an accident, death. Every year, 100,000 accidents occur in Pakistan only, out of which 50% are fatal. This highlights the understanding of our presentation today, the need for a topic of risk, safety, and accidents. I, Muhammad Hamad Ghari, along with Muhammad Hamad Ali Sheikh, will be delivering this presentation on the topic of risk, safety, and accidents. Now, even before we dive deep into the several different topics of this presentation, first of all, let's understand the flow of this presentation. Firstly, we'll be talking about the motto of this presentation. Secondly, we'll be establishing a strong understanding of the two terms risk and safety. Thirdly, we'll be talking about the link between safety and risk. Fourthly, we'll be talking about the different factors on which risk and safety are based on. Fifthly, we'll be talking about the criteria for a safe design. Sixthly, we'll be talking about the framework that is followed while designing for safety. Seventh, we'll be talking about the risk and benefit analysis. Eighth, we'll be talking about the three different types of accidents. And lastly, we'll be doing a conclusion in order to summarize this entire 12-minute presentation.
So the question arises that why should we bother to listen this presentation? Because being a mechanical engineer, it is our utmost duty to protect the safety and the well-being of the public. Because small measures that you make today is going to affect millions of lives. And that is the main purpose of our presentation. So now in order to develop strong understanding of this, we need to understand the definition of these two terms. What is safety? Safety is defined as freedom from damage, injury, or risk, or the condition of being protected from danger. Risk is defined as possibility of suffering harm or loss, or a situation involving exposure to the danger.
Now you see that both these two terms, safety and risk, are interlinked. We engage in risky behavior when we do something that is unsafe, and simultaneously, something is unsafe if it involves substantial risk. For example, while driving a car, it is advised to wear safety belt. Why? Because it increases your levels of safety, hence decreases the risk. Now we understand that both these two terms are inversely proportional. When one increases, the other one decreases. Now, before we go on, we need to understand what factors risk and safety are dependent on. And we'll be talking about five main factors. Firstly, voluntary versus involuntary risk. Many consider something as safe if the risks involved in it have been disclosed to them beforehand. For example, when we go to arena for ice skating, we see that we need to sign a document before we do that particular activity. That is an example of voluntary risk. We are aware of all the risks attached to that particular activity. Secondly, we have short versus long-term consequences. Now, now this means that something is which the effect of which are short-lived and which gives you a disability for a small amount of time is often considered as safe than something that could result in a permanent disability. Thirdly, expected probability. 1 in 1 million chance of severe injury is often considered to be safe, whereas a 50-50 chance of risk, which is although fairly minor, is considered as high levels of risk and is considered as unacceptable. Fourthly, we have reversible effects. Now, this means that the risks that are attached to a certain thing, all those bad risks are ultimately reversible. and all those risks which are reversible, that particular activity or thing or machine is considered as less risky. Fifth, we have delayed versus immediate effect. An activity whose harmful effects are delayed for many years is considered as safe or at least less risky than something whose effects are immediate and the risk and you are subjected to that particular risk immediately. That is considered as risky. Now you see that these safety and risks are really subjective. Why? Because it rests on these five main principles or ideas. So it is the duty of the engineer and his her company to use all their professional judgment to determine whether a project can be safely implemented. This can be a project of a car, a building, or a bridge.
Now that we have understand the fundamental criteria that we follow to create a safe design. So there basically comply with applicable laws. Means the design must follow with applicable laws. Alternative design that are potentially safer must be explored and searched. There should always be an alternative design. Thirdly, design must meet the standard of expected engineering practice. For example, ASTM, American Society for Testing Materials. This standard is mostly used in industry for materials. Fourthly, the engineer must be able to visualize all the potential misuse of a product. He must be aware of all that misuse and must include an additional factor to minimize the risk factor. This designing for safety, this type, firstly, because every product is essentially manufactured to solve a problem. Hence we first define a problem, including needs, requirements, and constraints. Secondly, we generate all possible solutions to the particular problem. Thirdly, we analyze. Fourthly, we test the solution, and based on that result, we select the best solution. And finally, we implement the best chosen solution. Risk benefit analysis. Risk benefit analysis is nothing but a comparison between risk and benefit. And here our goal is to figure out whether the risk or benefit is more significant to drive the best solution. Risk and benefits of a project are assigned dollar amounts. That means that project with high risk profile will typically have a large contingency budget. After analyzing, we chose most favorable, most suitable ratio between risk and benefits. This is often a very difficult task because it is difficult to design to what extent the risk is to be minimized. And dishonest assignment of a cost can lead to misuse of this technique. Now the types of accidents, there are three basic types of accidents: procedural, engineered, and systematic. Procedural accidents, most common accident category. This type of accidents are caused when we fail to follow the procedure and solution to it. So how it can be reduced? It can be reduced through increased training, more supervision, introducing new laws and regulations.
Now, secondly, we have engineered accidents. Now, these types of accidents are caused due to flaws in a particular product or a system. And these include three main things. Firstly, failure of material, that a material breaks. Secondly, devices that do not perform as expected. And thirdly, devices that do not perform well under all circumstances encountered. For example, your phone may not receive signals when you are high up in the mountains because over there you have internet signals issue. That is an example of the third point, that it is not performing well under all circumstances. Now you see that these engineered failures should be anticipated during the design phase and during the construction phase, and these should be caught and corrected during testing. So what's the solution to it? How can we reduce these engineered accidents? We can reduce them by testing them throughout the entire range, make the testing process more rigorous so that it includes all possible operating conditions. And thirdly, we have systematic accidents. Now, these types of accidents are the ones which are the hardest to understand and control because a series of minor mistakes or insignificant factors couple up over time, and under certain circumstances, they may have catastrophic consequences. Take the example of the building that fell during the rains in Karachi in the past few weeks. That was an example of a systematic accident because it was essentially minor cracks that were developed in the pillars. Now, those cracks were considered as insignificant and were not taken care of at the particular moment. Because of that, a catastrophe occurred. So in order to reduce these types of accidents, we need to pay scrupulous attention to detail and resist the urge to ignore or gloss over procedures and accepted engineering practice. We need to pay close attention to each and every detail that is occurring over time and need to deliver our best possible solutions to that particular product. Because like they say, a stitch in time saves nine. That's a solution to a systematic accident. So having said all that, let us drive a conclusion to this entire presentation. So firstly, we talked about the definition of safety and risks. Secondly, we talked about the different factors on which safety and risks are based upon and several ways through which we can determine them. Thirdly, we talked about the criteria, the framework that lays the foundation for a safe design. And fourthly, we talked about from an engineer firm's point of view of what to be kept in mind while we are designing any particular product so that it is safe. And thirdly, we talked about three different types of accidents: procedural accidents, engineered accidents, and systematic accidents. And we also talked about all possible solutions to those particular accidents. With that, we have arrived at the end of our presentation. Thank you so much for listening. Listening to this presentation. If you have any questions, feel free to ask. Reach out to us. My name is Mohammad Hamad Ghauri with my co-partner Mohammad Hamad Ali Sheikh, and here are emails. You can reach out to us through these emails, and we'll be more than happy to answer any question that you have. With that, thank you so much. Allah Hafiz.